Chins are a bit useless, so why do we have them? There are plenty of theories to explain why we have chins, but none of them stands up to scrutiny. Will we ever solve the mystery? Chins come in many shapes, but we all have them. Chins, we all have them, sitting a bit uselessly at the bottom of our faces. Some people have strong chins, others are said to have weaker chins. But if you were pushed to explain what chins are actually for, would you have a good answer? Nobody seems to use their chin for anything useful. Nobody had put forward a good idea about why humans would be the only animals with chins. It becomes even stranger when you consider that among the all primates, including our extinct relatives, only we have chins. Nobody seems to know why, although over the last century several theories as to its purpose have been offered. A review of all the previous literature now seeks to put some of these assertions straight. They chins are really strange, and that kind of drew my attention, says James Pampush of Duke University in Durham, North Carolina, who has been studying our humble chin for several years. Nobody had put forward a good idea about why humans would be the only animals with chins, so he set out to untangle the enduring puzzle of the human chin in a recent review. Even chimps don't have chins, their jaws slant inwards. We all have a pretty good idea what a chin is, but it's useful to define it nonetheless. Put simply, our chin is the protrusion of the bone that appears below the front wall of the human mandible lower jaw. No other animals have chins. Chimpanzee and ape jaws slant inwards, for instance. Even our closest extinct relatives such as Neanderthals did not have them. Nobody can quite agree why the chin exists. In fact, one of the ways that scientists differentiate between an anatomically modern human and a Neanderthal skull is by looking to see if it has a chin. That is what makes the appearance of chins in anatomically modern humans so interesting. It implies that there was some sort of behavioral or dietary shift between Neanderthals and anatomically modern humans that caused the chin to form, says Zanetta Thayer of the University of Colorado, Denver, another researcher who has studied the human chin. Although nobody can quite agree why the chin exists, there are three prominent theories that have been around for decades. To start with, it has long been proposed that our chin may help us chew food. The theory goes that we need the extra bone to deal with the stresses involved with chewing. However, this idea falls flat when you compare us to other great apes with similar shaped jaws. Our chins don't seem to help us chew. When we chew, our jaw gets pulled apart a bit like a wishbone, and the further apart our jaws are, the weaker the bones are. If we were to protect ourselves from the stresses of chewing, we would need more bone on the inner wall of the jaw near the tongue, not beneath our jaw. We don't have a very tough time chewing. That's exactly what you see in chimpanzees and macaques. They have extra bone on the tongue-ward side of their lower jaw, called a simian shelf, which we do not have. The added bone that forms our chin is not very useful for additional chewing strength. Another point Pampush is keen to make is that we don't have a very tough time chewing in the first place. Much of the food we eat is soft, especially cooked food. That's why the chin is not an adaptation for chewing, he says. Flora Groening at the University of Aberdeen in the UK, agrees. 5 years ago she used a computer model to look at the mechanical load on the mouth with and without a chin. There wasn't clear evidence to support the claim that the human chin is a result of a mechanical adaptation, she says. Orangutans may not have chins, but some males do have large cheek pads. Others have argued that our chin helps us to speak, that our tongue needs reinforcements from extra bone below our jaw. We are the primates with the most extensive speech repertoire after all. The issue here is that we don't need much force to speak, so it's not at all obvious why we would need extra bone to help with the process. And if we did need any extra bone, just like for chewing, it would be far more useful to add it to the inside of our jaw, closer to our tongue, rather than tagging it onto the bottom of our jaw. If it's an adaptation for sexual selection, then we are the only mammal that has the same in both sexes. The third idea is that the chin doesn't have an immediate function, but that it has been chosen by sexual selection. It is our equivalent of large flanged orangutan faces or a male elk's large antlers. These are traits that have both been selected for when the opposite sex is considering a mate. This ensures they live on in future generations even if they have no direct benefit or use. Again, there is a problem here, Pampush says. In all other mammals, only one sex will have a sexually selected trait. Chins, on the other hand, are found on men and women. If it's an adaptation for sexual selection, then we are the only mammal that has the same in both sexes, he says. Biologists borrowed the word spandrel from architecture. The three hypotheses mentioned all therefore fall flat, says Pampush. In fact, he argues that nobody can know why we truly have a chin at all. Anyone who tells you that they know why, is lying. Many of the ideas proposed so far have not stood up to scrutiny, he says, while others are untestable. Unfortunately, then, we are no closer to explaining why we have a chin. But if we look at it another way, it might become more apparent how it came to sit on our faces so prominently, despite having no functional use. Spandrels are a byproduct of a change happening elsewhere. It could simply be what's called a non-adaptive trait, that arises as a byproduct of something else. This is an idea that was suggested in 1979 by the biologists Stephen Jay Gould and Richard Lewontin. The chin, they said, is a spandrel. This is the name given to an architectural feature below some church domes that is often so ornate it looks as if it was the starting point for the building's design. In reality, spandrels only exist because they help support the dome above them. In other words, spandrels, both biological and architectural, are a byproduct of a change happening elsewhere. Archaeologists can use the absence of a chin to separate Neanderthals from modern humans. Our faces getting smaller may be what caused this particular spandrel to show, according to Nathan Holton of the University of Iowa. He says the chin may simply be a byproduct of the reduction of the human skull. Our mandibles, for instance, are less robust than those of our extinct hominin relatives. As our ancestors developed and used fire to cook their food, they no longer needed such strong jaws to chew. This means the overall strength of the jaw in turn became reduced. The appearance of a chin could have helped to maintain some of the strength our lower jaws once had. Other features changed too. We lack a prominent brow bridge and we have a hollow point below our cheekbones, technically called the canine fossa. These have also been linked to our smaller faces, Holton says. The presence of a chin is probably part of this trend as well. In this sense, understanding why we have chins is really about explaining why human faces became smaller. Groening also favors this idea, and says that the appearance of a chin could have helped to maintain some of the strength our lower jaws once had. Neanderthals and Homo erectus had such robust mandibles, they didn't need an extra thickening of the bone in the chin region, they already had strong jaws and robust bone, she says. Modern humans in contrast have very graceful bones. A chin might help to provide a bit of extra resistance to maintain a certain mechanical strength, but doesn't really increase the overall strength. Chins are a bit useless. On the other hand, a spandrel could also have been caused by a random event or accident, rather than as a byproduct of useful adaptations elsewhere in our faces. I am doubtful that it's an adaptation, says Pampush, but the problem is that for now nobody can prove it is an accident either. We don't have the tools to do so right now. The chin literally sticks out. So if none of the proposed theories fit the bill, and we cannot prove the spandrel hypothesis, you might wonder why Pampush has spent so long researching the human chin. It makes more sense when you consider that, although chins are pretty weird, studying them helps pinpoint the evolutionary processes that make us who we are today. It also exposes that evolution works in many ways. Perhaps surprisingly, it's also rare to find a trait that is uniquely human. Many traits that humans have, other animals do too. The chin, on the other hand, literally sticks out, and looking at how it did so may help us understand another step in the process that led to us